Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about algae to fuel extraction, meaning how the heck you have seaweed biofuel that actually comes to be in real world. So why do we focus on so much on seaweed? Well, reality is we all need a clean fuel, meaning if somebody says that they're going to have a battery powered basically jumbo jet, yeah, they're smoking weed, or there is a battery technology that you do not want to be nearby. You do not want to be near a battery that has that much oomph, because malfunctions do happen. Sooner or later, they do happen. But malfunction in RDX is very dangerous. So fundamentally speaking, if batteries, like, we know periodic table, we know how much electron travel we have, we figured all those things out. The surface area mathematics, again, nanotechnology could allow us to push it a little further, but not too much further. So jumbo jet is not going to happen. So what the hell we gonna do? And not to mention trucks also is not going to happen. It's like, no, there is a truck. Yes, deal. You can do whatever the heck you want to do. It's just, is it cost effective? Physics, engineering, and granddaddy layer, economics. Economics says no. Economics says flat out we need fuel, and hopefully clean fuel, so we have a future to live in. So why the heck people have such a bad reputation with biofuel? Well, reality is biofuel went through generations, Gen 1, Gen 2, Gen 3. So one of the bad decisions we made is figuring out how to make biofuel from plant-based material. Now, that was the dumbest decision ever made by any country anywhere. Now, the reason for that is we have limited resource known as fertile land and fertile soil, basically fresh water. And somehow we decided to compromise all of that for fuel. And because, again, government wanted to kickstart this industry, they gave subsidies. Consequence, every farmer compromised their fertile freshwater supplies for fuel. And fun fact, we need food more than we need fuel. We had survived without fuel for thousands of years. We will not survive thousands of years without basically food. So fundamentally, that created a very bad situation. Like, if you are like, why the heck people have such a bad reputation of biofuel? That's where it came from. Bad technology, basically. And don't even think this is a bad technology. Think of this like we did Mark 1 and we just ran with it. Rather than, okay, this is Mark 1, this is good, let's figure out Mark 2, let's figure out Mark 3. We just like ran with it, and that's bad. So LG is a better solution simply because it can happen in the sea, where you no longer have to worry about water supply or fertile land. And not to mention, you don't even have to worry about surface area. I feel like, oh, we need 100 square kilometer area. Sea is like, bro, that's nothing. Like, you will barely see that on a map. Like, that's so little that most nation, like for example India does not even have to go to international water. It's like, bro, in the zone that is national zone, like everything in that sea water is directly responsible by India. Like, nobody else talk about it. That enough has more than enough hundreds of square kilometer, hundreds of it. It's like we don't even have to worry about it. So algae is there. It has speed. What does speed mean? Simply means once you did the planting, how quickly can you get fuel out of it? That is measured in weeks, not years, months. Something like planted, done. And if done correctly, you can even get like almost every few days, not even week, few days, you can get that. And what about yield? This is also amazing. To give you a mathematical context of that, is that if you have palm oil extraction, so you're going to get 635 gallons of oil per acre per year. Not that great. Jatropha, like everybody has like Jatropha barely gives you around 207 gallons of oil per acre per year. Not that much. And again, you can go with corn, that barely gives you 18 gallons of oil per acre per year. Not that much. Hemp and all that, everything, it's very, very low. Now you come to algae. Algae is like, bro, 5,000 is the worst output. Best output goes up to 20,000. It's exponentially better. The worst algae can do is still exponentially better than anything else. That's why everybody is focusing on this. This is what we call Gen 3 biofuel. Does not have the penalty on food supply, does not have the penalty on fresh water supply. It does not care. It's out of the sight also. So you no longer have like, oh, people are looking at it. It's like, no, sir. No, you don't even have to look at it. You just have to make sure outside of visual horizon, curvature of the earth will hide it. You'll just like, nobody even get to see it. It's just something is there, some things come in, or maybe even a pipe comes in, and that's like, voila, your fuel is there. So this is why we have to focus. And benefit, we never have to change anything about our infrastructure. Like for example, biojet, what the heck this means? Nothing. Like if somebody says, oh, this SpiceJet has like green mile is running on, is this a new technology? No. All engines can inherently run on biofuel if the fuel quality is good enough. Flat out, there is no magical here. So fuel means fuel. Biofuel simply means it's made out of biology. Fossil fuel means made out of past biology. Nothing more than that. So do not have like, oh, biofuel requires engineering. No, if the fuel is done properly, nothing has to be changed. That's why like you have jet engines, jumbo jets that are certified. It's not a big deal. It's like maybe they have to figure out if they are not damn sure about the fuel quality, they will have some redundancy, spark plugging ignitions and all that jazz, but nothing else. So this is seaweed. So let's dive deep into it, biology. So we all need hydrocarbon chains. Why do we need hydrocarbon chains? Well, the smallest hydrocarbon you can have is methane, CH4, amazing puppy, natural gas. We fart it out. It works, quite amazing, but does not have the oomph. And not to mention it's gas, as in how much you can have in standard room temperature, is standard pressure, not that much, not that much. So it's good, but not that great. So we go down. We go down in hydrocarbon chain, basically reach a point where we reach LPGs, liquid petroleum gas, that is propane and butane mixture. At this point now you are talking about some density, some oomph, some kilojoule per megajoule per liter. You are starting to get better. Now you're going to pentane, heptane and octane. Now you're talking about gasoline zone. Now this gasoline zone is also called petroleum or petrol around the world. So this zone, basically C12 to C5, that's your gasoline zone. At that point in time, you go even deeper than that. You go to C13 to C15. These puppies are kerosene. Now, where is kerosene used? That's jet fuel. Kerosene, you take the kerosene, you refine the puppy hell out of it, and then voila, you get what we call JP1. You refine the hell out of JP1, you get RP1, rocket propellant one. So that's kerosene, C13 to C15 series. What happens if you go from C15 to below? C15 to C18 series, that makes the diesel puppy, diesel fuel, the most oomph in the fuel there is. Now it also goes below that, basically C20 to C70, but at that point in time you are in what we call petroleum product. And that's why, like, if you ever try to find out what is marine diesel, it's like very weird, different names you can get, because some people it's like marine diesel is just diesel fuel. For some there's no, a bunker oil is marine fuel. For that's why, like, it reaches basically below C20, it's almost lubrication oil. To give you a context, the fuel used in large container ships, those fuels are so solid in normal temperature, they need to be heated to almost 100 degrees Celsius just so they can move about. Otherwise, fuel pump will not be able to pump it unless it heats up to 100 degrees Celsius. Almost like tar-like consistency, like lubrication oil. So this is what we want. We want somewhere in gasoline or kerosene or diesel fuel. Diesel fuel is the perfect fuel. Like, it has all the characteristics amazingly well. So how the heck you build it? Well, you go down to the core level. What is core level? Hydrogen and carbon. That's the core elements here. So what gives you the hydrogen? Hydrogen is a hard thing to get by. Thankfully, water has what we call H2O. Okay, so you get hydrogen from there. Where do you get carbon from? Again, thankfully, atmosphere has CO2. That gives you carbon. Now, here's the deal. These things, when they react with oxygen, they do what we call exothermic, meaning they dump energy. You use that energy to drive your car, to fly your planes. That dumps energy. But how the heck are you going to bind them? Energy cannot be created nor destroyed. That simply means in order to build it, you have to expend energy. Thankfully, energy, there is a free source of energy known as the sun. There is no tax on it, so it's free. So that's how this thing on a fundamental core level works. Biology figures out how to extract hydrogen out of water, extract carbon out of carbon dioxide, and waste product is oxygen. We can live with that. We can live with that byproduct. I'm pretty sure we can live with oxygen as a byproduct. Now, why the heck so much focus on algae? Algae has, like, what we classify as very high lipid per gram of biomass. Now, why the heck is that? Well, if you ever paid attention to algae, you must have noticed one thing. It never has a structure, meaning it's floating. It never has, like, I'm going to fight with gravity, I'm going to stand it all. To do that, for even on a plant, even on a grass, it has to build cellulose. Cellulose is not that useful for you. You want lipid, you don't want cellulose. So a structure that does all the photosynthesis without requiring gravity, material that fights against gravity, is amazing. That is algae. Algae allows you to get lipids, very high amounts of lipid per ton of biomass that you create. Now, where is this lipid store, quote unquote? Well, almost everywhere in the cell membrane, that this structure that you see, these are lipid molecules. And how the heck every cell has energy consumption. So how the heck cell stops store energies on a fundamental level? Lipid. Again, there are whole category of lipid. Ask any your biology friend or biology major, they can explain it. It's far beyond my understanding, and the names are beyond stupid. It's like very complex things, but that's the whole point. Cell builds lipid as a structure and as basically energy storage. And again, cell level can do that. You cannot do that if you have to fight against gravity. That's why algae is a single cell organism, or even in a kelp form, where it's like, multicellular organism, is still not fighting gravity that much. It's floating. So fundamentally, it can do that. And what about other trace element? Because again, yeah, hydrogen and carbon, that's awesome. That's the core fundamental building block. Awesome. But it still requires other things like RDNA, DNA, all those things have things in it. So they just don't run on hydrogen and basically oxygen. hydrogen, oxygen, and carbon. They have other things, trace elements like phosphorus. It has very little. Compared to every other option, it has very little. So that's why it can even survive in seawater. So trace element requirement, meaning if you have to mine an area, like as in like this 100 square, how much nutrition you have to put if you are starting fresh? Very little. And how do you know you have lipid? Well, lipids are insoluble in water, exactly like oil and fats. So if you have like butter, cheese, oil, what the hell those things are? Those things are on fundamental level, this puppy. This is lipid. So lipid, you can notice that, like this is big boy. Now, can you use this as a fuel directly? Absolutely. Rudolf Diesel figured it out. That's the reason why Rudolf Diesel used to run his main engine. The first engine he built in 1880s, I think, was running on vegetable peanut butter oil, peanut oil, so to say. So that's the whole thing. And what all researchers are doing right now, like if you ask the researchers that are working on algae biofuel, what they are working on, like what are their main focus? Their main focus is increasing lipid content. They will always talk about, like, let's say this strain has 20% lipid content and this strain has 60%. That's an exponential difference. That's why, like, whenever you see any calculation for algae, it has such a wide range, because which algae strain you use, and be mindful, there are millions of the strain. You have to figure out which gives you the best bang for your buck. So if we reach a point where lipid content is very high, very, very high, the price of the biofuel will crash exponentially. So this is the core biological level. Basically, you have this molecule, and if you can break it off using some other chemistry, you can have, like, you know, these sort of puppy, gasoline puppy. Or some cooking process allows you to even make them heavier. Basically, if you want to bound longer chains of it, you can do that. You can go into petroleum product or even crude oil level if you want to go there. So this is on a biological level. That's why there is no limitation. There is no like, oh, how the heck are we going to get distilled water? How the heck are we going to get solar energy, solar electrical energy? Nothing. Base level, nature is taking care of you. You just have to circulate it. So how do we extract it? Well, the first step is you have biomass. Now biomass, the moment you extract the kelp, 80% water. You don't want water. So you have to dry it. How do you dry it? That's up to you. Some will use electric system, some will use solar furnace. Solar furnace is the best option. You basically dry it. The drier, the better. After that, you send the dry mass for oil extraction. Exactly like how we get coconut oil or anything like that. So there are many options. If you ever worked or ever watched any ads of oil, vegetable oil and all that, they will say we use this extraction process. Same thing happens here. So you have solvent based option where you can like put your coconut oil, you can put hexane in, then you can put methane in, triglycerin in, and all that jazz. You can like react to it and get right product output. Like you can separate exactly what you need to. Now this is a very complex process. Be mindful, this is what engineers get paid for in oil industry. I'm talking vegetable oil industry. Like there is a lot of procedure they have to do to get the most amount of useful oil out without damaging it. So yields are very good, meaning if you have how much was there, like let's say biomass had 100, how much you got out of it, almost 100% can be get out of chemical methods. But it is complex and expensive, meaning these procedures are, it requires serious engineering. It's not just you can just do it. Then we come to mechanical processing. Now mechanical processing, it's just simple thing. It's just like a screw compressor. That's it. You screw it down and you can even do hand crank it if you want to do it. That's it. Oh, be mindful, this is the solid waste that is coming out. We have to send it back into the sea. Right now we consume this solid waste because again, these are used in food products. We can't do that, because if we do that, we are removing many trace elements. We do not want to remove trace element. We want a sea to retain its trace element. We want to throw it back. Hey, see, have this trace element again, so your next generate batch does not have to worry about trace element. We always want to send trace elements back. We only want to extract hydrocarbon. Those are infinite. Why they are infinite? Because they are cycling. When you burn those fuel in your jet engines, what is the output? Water vapor and carbon dioxide. So it's cycling. It's carbon neutral. So mechanical process gives you okay yields, around 70% yield rate, and it's very simple and low cost. It does require oomph. Basically, it does require very high horsepower motors to, like, you know, do all that jazz, but it's dumb and simple and it can be done. These are the extraction steps. At this point in time, you have oil. Can you use it? Very heavy bunker oil user? Yes, you can use that. Normal car? No. This will like clog up injectors and all that jazz. Diesel oil will work, but like old diesel engine, modern diesel engine with very high pressure fuel injector, they will rarely work. So how do we process it? Well, at this point in time, you have oil. Now you have to extract exact liquid, basically lipid and hydrocarbon. Basically, you have lipid, you break it down into hydrocarbon. The lipid is a long chain, you want to break it down into hydrocarbons. Now, there are a lot of different processes you can, and that's why you will always watch multiple videos on, let's say, seaweed, and you will always find, oh, we are making basically methane out of this seaweed, we are making crude oil out of this seaweed, we are making plastic out of this seaweed, we are making this out of, like, how the heck that is happening? Again, the processing process allows you to select what exactly you need, meaning you can choose ethanol. Again, why would you do that? But let's say you could do that. Crude oil, again, desirable if your country is like completely dependent on export, and you have, let's say, for example, in India, we have a lot of refineries that handle crude oil. It would be wise from our economics point of view that, like, just make crude oil, give this to all the refineries, and refineries will sort out all the stuff. It is bit inefficient, meaning instead of, let's say, 100 square kilometer, we have to consume 110 square kilometer, but it does not have economic side effects, whereas, like, what the hell refinery is gonna do? And not to mention, you have every single product stack taken care of. Only this C70 and above series are gone. That you're not gonna get. There are some process that allows to try to achieve that, but it's not that useful to get bitumen, that much bitumen asphalt and all that. That's not that desirable. But you can get to C20 to C70 series, which is heavy fuel oil used for marine engines. So you can get that. So you have to select what you want to do. You can get ethanol, crude oil, it's your choice basically. Biodiesel, super easy. And now there is a process known as it's a very weird name. Transesterification. I'm very sorry. I've linked the video down below where a person shows how to do that from oil, vegetable oil to actual biodiesel, quote unquote. You can do that with household products. I have linked the video down below. This process that gives you biodiesel. And can you use that biodiesel directly in your diesel car? Yes, but you should not, because be mindful there are a lot of additives in modern diesel and petrol also. So those additives, if your car engine is not getting those additives for long term, it might break down. It's requiring the car engine, like, that's why you always see, like, new emission standard and fuel and car engines both come as a package deal. It's like, you have to use BS5 engine on BS5 fuel. That's the reason. There are additive handshake there. So you can do that, especially old engines. They're like, dude, I don't care, I'm gonna run on it. Then you have pyrolysis. Basically, you cook this puppy. Super simple process. Then you have micro emulsion process. Again, far more complex, but again, you have a choice which gives you different kind of yield rate. And each has their own pros and cons. Some have very good energy requirement, as in, like, it consumes very little energy. Some consumes a lot of energy, so your yield rate goes down. Or some companies are saying that we're gonna have offshore oil platform, old oil platform, using as a base, where we're gonna have a lot of wind farm. Because be mindful, what we are paying for is liquid fuel. We have energy, we have solar energy, we have wind energy. What if we use wind energy in those sort of location to get more liquid energy? So for that reason, some processor may be preferred, because if it improves yield but consumes a lot of power and you can provide that power from, let's say, wind farms, that may be preferred. So all of them have their pros and cons, and market demand will select the price. Because, let's say, again, India has a lot of oil refinery system, crude oil refinery systems. We can just, like, make crude oil, even though it will consume a bit more square kilometer. We don't have shortage of that, and we do have a lot of refineries, so we can just, like, go ahead, and India will never notice that we switched from carbon positive fuel source to carbon neutral fuel source. Nobody will know, and everything will go on fine without polluting the air, as in, like, with carbon dioxide. So what are the problems with this? It's like, this sounds amazing, right? It's a known technology, and I'm talking like ancient individuals like Rudolf Diesel, Henry Ford, and, like, corn oil and all that jazz. Those things have been sorted out for a very long time. So what's the problem? Why the heck we don't have it? Well, science is clear. Let me be very clear. If anybody says on science it does not work, they're smoking weed. Flat out, science is clear, and that's why I always specify. You have physics, engineering, economics. Physics, flat out. This is the only fuel we can utilize for our modern day lifestyle. If you want to let go of your modern day lifestyle, like let go of your jet, let go of high energy consumption, let go of your cars and all that, yeah, you can go to something else. But if you want modern day lifestyle, you have to use this. Why? There is nothing that has the same energy density. Be mindful, not capacity, density, and it's carbon neutral, meaning it does not contaminate our planet. It works exactly like how we do. We consume food, we burn it in our tummies, breathe out carbon dioxide. That carbon dioxide is consumed by the next crop cycle. Everything goes fine. We are just consuming mass in the sun. That's all we are doing. Mass is consumed, photons are reached, photons is cycled by the photosynthesis, and cycle goes on and on and on. We don't never have to worry about it. And what about emissions, quote unquote? I'm not talking about pollution, I'm talking about emissions. Again, emissions also goes down, because unless you are deliberately putting sulfur and mercury there, those things won't be there in the fuel source, meaning you're gonna have cleaner air. Like, I'm not even joking. Like, I did not even knew that sulfur contamination is a thing. And again, those are the things that is done in JP1 and RP1. They try to remove as much sulfur as possible. Like, how the heck sulfur is going there? Again, it's coming from the ground. So if you do not have sulfur and mercury, again, contamination will go down drastically. Now let's come to alternatives. Basically, people who are like really did not study the history. Liquid hydrogen. Everybody's like hydrogen. Hydrogen has liquid hydrogen barely has 8.5 megajoule per liter. That's chump change. That's nothing. Now, here's the deal. Everybody's talking like we don't have energy density. It's like, did entire humanity forget that we have a periodic table? And the first element, the lightest element is hydrogen? Like, liquid hydrogen does not have enough energy. Now, again, some people are like, what if you use ammonia? Sounds good. 11.5 megajoule per liter. But here's the, it's toxic to human, and 11.5 is still not that high. And be mindful, this requires pressure tanks, not ambient temperature, ambient pressure storage. That's why liquid fuel matters us to. Like, we want something that I can store in a water bottle. You can store basically diesel, petrol, things of that nature on a water bottle. Nobody cares. It can be done. Diesel, especially diesel, is also safe. So we can do that. Now let's compare it to biofuel, the actual energy content. Biofuel can give you 37.7 megajoule per liter to 36.97 megajoule per liter, because I specified you get to choose where your C series is, C15 series or C20 series, and that will give you the range of this. Even with conversion inefficiency, this puppy is so much more. Unless you are using 100% of basically liquid hydrogen, you still don't come to close. And not to mention, liquid hydrogen cannot be used for planes. Why? We have tried it in 1950s. Military tried it. Everybody tried it. Everybody outcome was always the same, that you have to use basically normal JP1 in order to take off, go to the altitude, and very high altitudes reconnaissance planes. That was the deal with military system. They wanted to figure it out that at very high altitude, because again, it does not have to suffer what we call flame out. It was a good tool, but again, does not, like, you are carrying basically normal JP1, might as well improve the engine ignition system so it can handle the flame out condition. Yeah, it started to work much better. That's why military abandoned that part. And not to mention, Boeing engineers are working on that. Again, you can look at it. It's like they are experimenting on Airbus A380, giant puppy, 4 amazing engines, and they are putting on a tiny engine, and they have giant tanks, liquid hydrogen tanks, giant hyper expensive liquid hydrogen tanks. And again, why liquid hydrogen? Again, liquid hydrogen is lighter compared to pressurized hydrogen. Pressurized hydrogen, while hydrogen is light, the tank is very heavy. So in planes, weight matters. So for that reason, they have to use liquid hydrogen. And if you look at the diagrams that they are showing, it's like, yeah, they have a boil off tube. Because here's the deal, you cannot put your plane in a runway if you have liquid hydrogen in it. Why? It will boil off. That's why even for rocket launch, we just fuel it and throw it. It's like fuel, throw. We don't have the ability. Like, it has to be constantly topped up. And somehow you're gonna run commercial airlines with it. Like, what are you smoking? And this comes to another aspect. Like, many times people will counter it, is that engineers are working on it. Like, I have very huge amount of respect for Linus Tech Tips. I've been following him for 10-15 years. And he said something that was profoundly stupid. It's like, Hyperloop is not stupid because the engineers are working on it. It's like, these people they have graduated and all that. Just here's the deal. Things happen. And anytime you say things like that, it generally means you have no idea that people exist as engineers. Engineers are not this godlike thing. They are human. What does that mean? It simply means, if you ask me engineer to do something stupid and you pay them, they will do it. Like, every engineer working on Hyperloop, they knew, like, I can give you 10 problems with Hyperloop. They're going to give you 10,000, page PhD on it. It's like, it's not going to work. Then why the heck they were working? Again, they're getting paid. Like, if you pay me to do something, I will do it. That's first. Second, bans and dump people. For example, let's say everybody started to yell. It's like, we're going to ban hydrocarbon. We're going to ban hydrocarbon. What the hell Boeing engineers going to do? What the heck Boeing company is going to do? They know for a fact that ammonia is not going to work. They know for a fact that ammonia is toxic. So what the hell they're going to do? What is the worst option that you have? Liquid hydrogen. They know better than me. Like, every engineer, like for example, when space shuttle was built, engineers knew this is a dumb idea. They wanted to scrap it. They were like, dude, this is a dumb idea. Dumb. But again, they were getting paid to do it. So dumb public and bans always leads to a point where you have forced engineers, meaning they're like, they have no other choice. They have no other choice. What else they're gonna do? Like, they know for a fact that Rudolf Dieselfrom figured it out, Henry Ford figured it out. And again, those were problematic options because they were Mark I products. But we have Mark III now. Why the heck we are not focusing on that? Like, we have jet that works on biofuel. Nobody even talks about it because it's boring. It's like hydrogen and this and that. Is like, think of it this, like that's how inferior hydrogen is, that your Airbus A380 is capable enough that if failure of one engine happens, it does not even notice it. It's like, bro, I got this. So why don't experiment on one? And that's how it's done. Many times when biofuel has been experimented on, they experimented on one main engine. Why the heck they did not do it? If they tried it on Airbus A380 main engine, yeah, the hydrogen tank's gonna run like this. Khatam sir, done, empty. That's how quickly it's gonna run out. That's the problem with 8.5 megajoule per liter. That's why they are not experimenting on the big daddy engines. They're experimenting on tiny engine where your fuel tank is larger than the engine itself. So that's why engineers are forced. They can tell you, like, ask them down, sit them down, pay them, and they're gonna tell you 10,000 reasons why it's not gonna work. So but again, if they are surrounded by politicians, is like, who's like actual lawyer, somehow became a politician, somehow it's like, I'm deciding what's the engineering gonna do. What the hell they're gonna do? So forced engineer means that's why this sort of project happens. People working in Hyperloop knew this is not gonna work. It's just that they were getting paid. Another aspect is, it's always stuck in chicken and egg scenario where it's like, oh, it's expensive. That's what the common dumb thing people will say, it's expensive. You see, everything is expensive. It becomes cheap with more investment. People are like, I'm gonna invest in it when it's cheap. It's like, no, that's not how it works. You invest first, then it becomes cheap. For example, 1973, mobile phone was idiotically expensive, but somebody took the ballsy step to like, I'm gonna invest in it, I'm gonna build a cell network, I'm gonna do what I need to do in order to get this puppy working. Then more people invested in it. Again, this better puppy happened. 2004, even better puppy happened. iPhone happened in 2007, even more. Samsung Fold happened recently, even more better. That's how it was. You invest, that drops the price. Never is like, oh, when the price is low, then I'm gonna invest. That's not how it works. For example, real world, mobile phones, solar, computers, all of these things became cheap. Like, for example, in as early as 2010, look at the price. Basically, this is from all countries, China, India, USA, and all that. Like, look at the price graph, how quickly it dropped. And I'm talking from 2010 to 2020. If you compare it to 2000 to 2020, only 20 years, meaning younger than me, the graph is mind-boggling. Like, we went from almost touching 40 cents per kilowatt hour to almost like few cents per kilowatt hour. And again, if I had told you just 15 years ago that India is going to have solar farms that are gigawatt hour, they're like, dude, what are you smoking? But we have it right now. Why? Somebody took the plunge. Somebody was like, let me invest in it. If the core technology is sound, the price always comes down. Let me be clear. If the core technology is right, price will always come down. Same happened with computer. Intel took a risk on it. Price started to come down. ARM's holding took a risk on it. Price started to come down. That's how it works. You invest, that's how price come down. Everybody is like, I'm gonna waiting for it. And again, government is like, they don't know any better, so they're like, we're gonna ban it. It's like, again, whatever investor wanted to invest in it, they're like, dude, I get it. Even if some investors are really smart, they know it. They're like, dude, I'm not gonna risk my money because government is gonna ban it. And who's gonna teach government? Be mindful. People much smarter, much more capable, much more wiser than me came and went. Like 1950, that's when we figured out hydrogen is not going to work. 1950, 1978, if I'm not mistaken, the oil embargo happened, and that's the time when all the research was redone. They figured it out. Other than biofuel, nothing else can work. Nothing can work. But we are like, we're going to do ammonia. It's like, it's toxic to us, and it does not even have energy. How are we going to do hydrogen? It's weak. It's the lightest thing. It's like, we have biofuel, we have sea, we have sunlight. Let's just do it. But that's the reason. That's why you do not see, like, stuck in that more investment, low cost, and forced engineers that have to work on other things rather than useful thing like this. So that's why, like, do not let anybody persuade you by saying like, oh, it's expensive. Yeah, it becomes cheap when you invest in it. And every time India invests in, like, let's say 1 gigawatt solar farm, next farm becomes even cheaper. That's how it happens. Like, if we start to do it today, even though today, let's say, it's 3 times more expensive than normal crude oil, we do it, oh, it's like only 2.5 times more expensive. We do it more, oh, it's like only 2 times. We do it even more, now it's like cheaper than crude oil. That's how it happens with everything. So that's the chicken and egg scenario. So this was my presentation on basically what the hell is, how the heck you get basically oil out of seaweed. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.